Welcome to LIB Academy, and in this video I'm going to take you through partial derivatives of functions. So from our previous lessons on calculus, we'll learn how to find the derivative of functions which normally depend on one variable, right? So let's say f of x equal 2x squared plus 2, and we learn how to find the derivatives of those functions. And this is simply, let's say we have our line, assuming this is a line f of x equal 2x squared plus 2, and we want to know what will happen to the function f of x or the line if we vary the value of x, right, by finding the derivative of x, right? So in this case, let's say we have area of a substance that depends on the length, let's say the width and then the height, right, which is x and y. And we want to know what will happen to the area of that substance if we vary only the length, right? Let's say this one is of 2x plus y. You might want to know what will happen to, let's say this one is a rectangle. What will happen to the rectangle if you vary the value of x, or if you vary x leaving y constant, right? Or you might want to know what will happen to the function if you vary y leaving x constant, right? So this then takes us to partial derivatives, where we find the derivative of one of the variable leaving the other constant. Fixing the other variable. So you might also have a cylinder. Now let's take it to be a box, which area depends on the length, height, and the width. And you want to know what will happen to the area of the box if you change only the width, right? So this is all about partial derivatives. So let's start. And it's just simple. So I urge you to take note during this lesson. So one thing we would like to also look at is the terms, the notation for partial derivatives. So let's say I have a function that depends on y and x. Let's say f of x, y equals 2x plus 3y. And I want to find the partial derivative of f of xy with respect to only x. So I can write it as this way. Partial derivative, this is a symbol for partial derivative of f with respect to x, right? I can also write it like this, simple. So this means that I'm going to differentiate this function with respect to x, leaving y as a constant. So if it were to be y2, you can also represent it like this, the partial derivative of f or partial derivative of y. You can also represent it like this. So now let's start. Find the first partial derivative of f of x, y equal 2x squared y cubed with respect to x and y. So to do this, so our function f of x equal 2x squared y cubed, and we have to find the partial derivative of this function with respect to x and then y. So we can say the f or the x equal. So what we do is that what we are going to do is that since we are differentiating with respect to x, we only differentiate the x term, leaving the others, leaving the other terms. So in this case, this is going to be 2 differentiating x squared. To differentiate something like x squared equal, we multiply everything by the power, and the power will decrease by 1, right? So we have 2 decreased by 1. So this is going to give us 2x, right? X cubed going to give us 3x, then you decrease the power by 1 squared. So that's what we are going to do. So 2, we multiply x, 2 by x, then the power of x is going to decrease by 1, which is 2 minus 1, giving us 1. So this one is right. Leaving this y, keep as a constant. So simplifying this further, we are going to get 2 by 2, which is 4, and then x, then y cube. So that's it for the f over the x. Mind you, you can also represent this as fx, which means the partial derivative with respect to x. So now let's do for y. So for y, partial derivative with respect to y, we are going to differentiate only the y term, leaving the others. So 3 by 2, so let's say 2x squared multiplying 3 by y, and then the power will decrease by 1, which is 3 minus 1, so giving us 2. So simplifying this further, we are going to get 3 by 2, which is 6x squared, then y squared. So that's it for this question. So we found the partial derivative with respect to x and with respect to y. Assuming this is the area of a substance that depends on its length and then weight. So this is what will happen to the substance if we vary the function with y, and this is also what is going to happen to the substance if we vary the function with respect to x. Find the partial derivative of f of x y equals 6x squared minus x squared minus x cubed y to the power 5. So to do this, let's start with partial derivative of this function with respect to x. So in this case, we are going to differentiate only the x terms, right? Only x, leaving y, right? So we have 6 here by 2. So 6 differentiating x squared, we are going to get 2x to the power 1, right? 2 decreased by 1. So minus differentiating x squared is going to give us 2x, right? Minus differentiating x cube is going to give us 3x to the power 2, and then y to the power 5. Since we are not differentiating with respect to y, just leave it like that. So let's simplify this further. So 6 by 2 is going to give us 12x minus 2x minus 3x squared y to the power 5. So that's it for f of x. So now let's find the partial derivative of this function with respect to y. So with respect to y, we are only going to differentiate only y, leaving the x terms. So in this case, if we have a term that does not contain the variable that we are differentiating with respect to, then that term goes 0, right? So for instance, we have 6x squared here. This doesn't contain y term, which we want to differentiate with respect to. We have x squared here, which does not contain y term, which we want to differentiate with respect to. And so those go 0. So 6x squared 0 minus x squared 0. Why? Because they do not contain a variable of interest. So, and this one, we are going to differentiate this. We have our y here. So let's say we have x cubed. Differentiating y to the power 5, we are going to get 5 multiplying by y, and the power will decrease by 1, giving us 4. So this is going to give us, we can just ignore all this. So we are going to get minus x to the power 3 multiply. This dot means multiplication, right? So we can just simplify everything else. Let's let 5 to come here. It's a negative, right? X cubed y to the power 4. So that's it for this question. Find the partial derivative with respect to x and y of the function f of xy equals 7x squared minus x squared y to the power 3 plus 5x to the power 4 y to the power 3 plus 5. You can pause the video and try this. So we are starting with the partial derivative of this function with respect to x. which we can represent it as the f partial derivative, the f over the x, since it is with respect to x. Or we can also write it as, since the function is fx, right? So any one of these, any of these is allowed to use. So now we are finding our f or fx, right? So our fx, we are going to differentiate only the x, the variable, the term with x, or x terms, leaving the y terms, right? So here we have 7x squared. So 7 differentiating x squared will give us multiply by 2x to the power, 2x to the power 1, right? So minus differentiating x squared going to give us 2x, right? Y is not a variable of interest. We'll just leave that one as it is. Plus, we have 5x to the power 4, right? We are differentiating x. So we have 5 here. Differentiating x to the power 4. Differentiating x to the power 4 gives us 4x to the power 3, right? And then y to the power 3. And differentiating a number or a constant is, equal 0. So a constant equal 0. So let's further simplify this. 7 by 2 gives us 14. So 14x minus 2xy to the power 3. And then 5 by 4 is going to give us 20, which is a plus 20, x cube, y cube. So that's it for f of x. So let's do for f of y. For f of y, we are only going to differentiate the y terms, right? And a term that does not, contain x, y term goes 0. So we have 7x squared, which does not contain y term, so equals 0. So 0 minus, we have x squared y cube, right? We are differentiating with respect to y. So differentiating this with respect to y, we are going to get x squared. So differentiating y to the power cube gives us 3y to the power 2 plus, and this one too, we have 5x to the power 4. Differentiating y to the power 3 gives us 3y to the power 2. So let's simplify this further. So this is going to give us 3, which is a minus 3x squared, and then y squared plus 3 by 5 gives us 15, right? 15 x to the power 4, y to the power 2. So that's it for this question. Find the partial derivative of z equal 2x squared y to the power 4 minus 5x to the power 7 plus 4y to the power 8. So we first start the partial derivative with respect to x of this function. And in this case, the function is z, right? So this is z of x, not f of x. So of fx, sorry, not fx. This is zx. So we are going to differentiate with respect to x. So any x term that we see, we differentiate it in the others. So we have 2 differentiating x squared gives us 2x to the power 1. And then y, just write it as it is. So minus 5 differentiating x to the power 7, we have 7x to the power 6. The power is going to decrease by 1. And for y to the power 8, we don't have any x term there, so it goes 0. So let's simplify this further. So 2 by 2 gives us 4, y to the power 4, minus 5 by 7 gives us what? 35, x to the power 6. So that's it for z of x. So let's do it for z of y. Z of y equal, in this case, we are going to differentiate with respect to y. So we have 2x squared. So 2x squared differentiating y to the power 4, we are going to get 4y to the power 3. And we have minus 5x to the power 7, which does not contain y term, so it goes 0. So minus 0 plus 4y, differentiating 4y to the power 8, we have 8y to the power 7. Like I said earlier, this dot means we are multiplying. So Let's simplify this further. We're going to get 2 by 4, which is 8 x squared y cubed, and then this 0, so plus 4 by 8 gives us what? That is 32. Y to the power 7. So that's it for this problem. Find the values of the f dx and the f dy at the point 4, minus 5 if f of x, y, of x and y, f of x, y equal x squared plus 3xy plus y minus 1. So in this problem, we are going to differentiate, and which is a partial differentiation, differentiate with respect to x and then with respect to y. So let's start with the f, the x. So in this case, we are differentiating with respect to x. So differentiating x squared gives us 2x. We multiply this by, we multiply the power. We multiply the term by the power, and the power decreases by 1. And differentiating 3xy with respect to x. So we have 3 multiplied by 1, and then x goes 0. The power is 1, so minus 1 equals 0. So y, right? Mind you, we are differentiating with respect to x, and a term that does not contain x goes 0, so y goes 0, and constant also goes 0, right? So let's continue. So in this case, we are going to get 2x, 3 by 1 and y, so giving us 3y. So that we should find the value of the f, the x at the point 4 and minus 5. So at 4 minus 5, so the f, the x equal, this is the value of x and this is the value of y. So 2, the value of x is 4, so 4 minus, plus 3 into bracket value of y, which is minus 5. So this is going to give us 2 by 4, 8, and 3 by 5, which is a negative 5, giving us minus 15. So 8 minus 15 going to give us negative 7. So that's it for the f, the x. So let's do the same for the f dy. The f dy equal, in this case, we are differentiating with respect to x. And this term does not contain, we are differentiating with respect to y. And this term does not contain the value of y, so it equals 0. And we have 3xy here differentiating. So we have 3x differentiating y to the power 1 gives us 1, right? Differentiating this also gives us plus 1. And a constant goes 0, minus 0. So let's simplify this. We're going to get 0 plus 3x multiplied by 1, which is 3x, and then plus 1. So this is our df dy. So at point 4 minus 5, our df dy equal, wherever we see the value of wherever we see wherever we see x, we substitute the value of x there. So 3 by 4 plus 1. We don't have y term yet. So this is going to give out 3 by 4, which is 12, plus 1 equals 13, right? That's it for this question. If f of xy equal x cube y minus xy cube, find 1 over fx plus 1 over fy at x equal 1, y equal 2. So in this case, let's start by finding the partial derivative with respect to x and then y. So fx equal differentiate with respect to x, so x cube, we get 3x squared, then y minus differentiating x, we get 1, so minus y cube at x equal 1, y equal 2. So let's substitute the value of x and y into this final equation. So x is 1, so x 1 squared, and then y is 2. multiplying 2 minus y to the power 3. Y is 2, then to the power 3. So 3 by 1 to the power squared by 2 gives us 6, right? 6. And 2 to the power 3 gives us 8. So finally, we are going to get minus 2. 6 minus 8, which is minus 2. So let's find out of f of y. F of y, and in this case, we are differentiating with respect to y. So we have x cubed. Differentiating y gives us 1, right? So minus x, and differentiating y to the power 3 gives us 3y to the power 2. So let's simplify this. This is going to give us x to the power 3 by 1, which is x to the power 3, minus 3, let's bring 3 here, xy squared. So at point x equal 1, y equal 2, let's substitute the values in. So our x equal 1, so 1 to the power 3 minus 3 into bracket 1, and our y is 2 here. So 2 to the power 2. And 2 to the power 2 gives us 4, right? And then 4 by 1 is the same as 4. 4 by 3 giving us 12, right? 12. So minus 12. And then 1 to the power 3 is the same as 1. So this is going to give us 1 minus 12, which equals minus 11. And we are asked to find the value of 1 over fx plus 1 over fy. So in this case, we have 1 over fx plus 1 over fy. And then our fx, the value for our fx is right here, which is minus 2. So this equals minus 1 on 2. 1 on 2, which is the same as 1 on minus 2, which is the same as minus 1 on 2. And then we also have 1 over fy. So plus, it should be plus, but in this case, minus, let me write this, 1 on 11. So in this case, the negative sign is going to dominate, right? You're going to get minus half minus 1 on 11. Let me punch this on my calculator and see what we get. This is going to give us minus 13 on 22. So that's it for this question. Evaluate the first partial derivative with respect to x, with respect to y at fy 1, 2, 2. So what we need to do before that, let me give you the function. If we have f of x, y, z equal 2xy squared plus 3z. So that is a function. So fxy z equal 2xy squared plus 3z x cubed plus 3y z to the power 4. So let's start with, and in this case, we have to find fy and evaluate it at 0.122. So let's find the partial derivative of this with respect to y. The partial derivative of this function with respect to y. So with respect to y, we have 2x, and differentiating y, since we are differentiating with respect to y to the power 2 gives us 2y, right? And then plus, we have 3zx to the power 3 here, and it does not contain y10, so sorry, it goes 0, right? Plus, we have 3y here, so differentiating y to the power 1 gives us 1, we just no need to write it. Then z to the power 4. So simplifying this further, we are going to get 2 by 2, which is 4, x here, y here, plus 0, and then 3z to the power 4 plus 3z to the power 4. And then we have to evaluate fy at 0.122. So in this case, fy at 0.122 is going to give us, we have 4 here, and x is 1, y is 2 plus we have 3 z to the power 4. Z is also 2 to the power 4. So 4 by 1 by 2 gives us 8. Then plus 3 2 to the power 4 gives us 16, right? And then 16 by 3 gives us 48 plus 8 right here. Going to give us 48 plus 8 gives us what? 16 and 56. So our final answer for this is 56. F x y z equal x to the power 5, y to the power 2, z to the power 4. Find fx, fy, and fz. So we are going to find the partial derivative of this function with respect to x followed by y followed by z. So this is a function of three variables. The same principle hold. You just differentiate the variable with respect to and then leaving the rest. So now we are going to look for f of fx. So in this case, we are differentiating with respect to x. So differentiating x to the power 5 gives us 5x to the power 4, leaving the rest as they are. So that's it for fx. So let's do it for fy. In this case, we are differentiating with respect to y, leaving the rest as they are. So we have x to the power 5 with respect to y gives us 2y to the power 1, right? And z to the power 4. So let's further simplify this to 2x to the power 5, y, and z to the power 4. That's it for fy. So let's find z. Fz is going to give us, we are differentiating with respect to z in this case. So we have x to the power 5, y to the power 2, and differentiating z to the power 4 gives us 4z to the power 3, or it's going to decrease by 1. So now, going to get, let's simplify it, 4x to the power 5, y to the power 2, z to the power 3. So that's it. Find the slope of the surface in the xy direction at the point 3, 2. We have f of x or y equal x cube y cube. So we are to find the slope of the surface in the x and y direction, right? So in this case, we have to find the partial derivative of this function with respect to x and evaluate it at point 3 and 2, and also with y with respect to x, and the partial derivative of f of x with respect to y and evaluate it at point 3, 2. So let's start. So first of all, let's look for fx, which is called differentiate with respect to x. So x cube, differentiating x to the power 3, we have 3x squared, then y cube. Then at point 3, 2, we can just substitute the values in and then evaluate it. So we are going to get 3, x is 3, right? So 3 squared, and and then y is 2, right? So we have 2 to the power 3. So let me just point this on my calculator, straightforward. You should be getting 216. So now let's go for fy. Fy, we are differentiating with respect to y, and this is the function x cube, x cube, y cube. So x cube differentiating y to the power 3, we have 3y squared. So further simplifying this, we have 3x cube y to the power 2. So at point 3, 2, we just substitute the values in, right? So we have 3. X is 3, so 3 to the power 3. And then y is 2, so 2 to the power 2. So let me just punch this on the calculator straightforward. Our final answer should be 324. Find the partial derivative of fxy equal square root of x squared plus y squared with respect to x and then y. You can pause the video and try this. Then you know that square root of any number or a variable is the same as that variable raised to the power half, right? So we can rewrite this function as, this function can also be written as x squared plus y squared. So in problems like this, we have to use the chain rule, right? The chain rule. So keep in mind, problems like this, we use the chain rule. So in the chain rule, what do? We multiply everything by the power. So let's say we are differentiating with respect to x. So we multiply everything by the power. So the power, and then what is the bracket? X to the power 2 plus y to the power 2. And the power is going to decrease by 1. So minus 1. And then now we differentiate what is inside. And in this case, we are differentiating with respect to x. So we just differentiate the x term, leaving the term that does not contain x term to go 0. To go 0. So in this case, we have x squared plus y squared. This term goes 0. And we differentiate x squared because we are differentiating with respect to x. So we are going to get 2x. That is a differential for x squared. So further simplifying this, we are going to get half x squared plus y squared. 1 minus 1 gives us minus 1 on 2. Then we have 2x, right? Looking at this, we notice that, let's rearrange this before that. So let me bring 2x here, multiplying half to the power x squared, y, to the power x to the power 2, y to the power 2, all to the power minus half. We see that these two take care of these two. So remaining x multiply x squared plus y squared all to the power half, right? So this is our final answer, but you can then go ahead and simplify this further. So this will give us x all on x squared plus y squared. We know that to the power half means square root, right? And the reason why I'm doing this is that from indices, if I have 1 to the power, 1 over 2 to the power 2, I can also write it like this. The inverse of 2 to the power 2. 1 over 2 is the same as 2 to the power minus 1, means the inverse of 2. And from this point, I know that this is to the power half. And to the power half means root, right? Root of that. So, and it is minus means the inverse of that. So that's why we got this. And now this is with respect to x. We are also going to do the same with respect to y. So you can pause the video and copy that. All right. So let's do respect to y. So fy going to give us we are going to differentiate with respect to y. So let's bring the power. We are using the chain rule. Then everything in the power is going to decrease by 1. So half minus 1. Then we now differentiate what is in the bracket. In this case, we are differentiating with respect to y. So the term that does not contain y goes 0. So y to the power 2, differentiating that, we get 2y. So further arranging this, we get 2y, or 1 on 2, on x squared plus y squared. Half minus 1 gives us minus half. So as usual, let's take care of this. We are going to get y x squared plus y squared all to the power minus half. And this is the same as inverse. Mind you, this power only affects this term, right? So we can write this as plus y to the power 2. So that's it for this question. Find the partial derivative with respect to z of cube root of x, fifth root of x cube plus y cube. So how do we do this? We can rewrite this whole term to our z equal. Mind you, always we are trying to put the problem in a form that will be easier for us to solve, right? Good. So we have x to the power 3 plus y to the power 3 all to the power 1 on 5. Now, if you are wondering how we got that, if we have square root of 2, it means 2 to the power 1 half, 1 on 2. If we have cube root of 2, it means 2 to the power 1 on 3. If we have fifth root of 2, it means 2 to the power 1 on 5. What if we have cube root of 5? Fifth root of 2 to the power 2. So we are going to get, as usual, let's transform this first. So we get 2 to the power 1 on 5. And this power of the term under the root sign comes here, 2 here, right? So that's it. So if we have fifth root of 2 to the power 3 plus 4 to the power 3, we can represent this as, 2 to the power 3 plus 4 to the power 3, all to the power 1 on 5. 1 on 5. So let's continue. We are differentiating with respect to x. So z of x, zx equal, as usual, like we are going to use the chain rule here, right? So 1 on 5, we bring the power here, multiply everything by 8, and decrease the power by 1. And now we differentiate what is inside the bracket. First of all, we multiply everything by the power, and write everything decrease by the power by 1, and differentiate what is in the bracket. But in this case, we are doing with respect to y. It's a partial, it's partial differentiation. So the term that does not contain x goes 0 because we are differentiating x. So we're differentiating x to the power 3. So x to the power 3 gives us 3x squared. So let's further simplify this. 3x squared by 1 on 5. X to the power 3 plus y to the power 3 all to the power 1 on 5 minus 1 gives me, again, that is minus 4 on 5. Yes. So I can read out this as, let's say, 3 on 5 to x to the power 3 plus y to the power 3 all to the power 4 on 5. Well, on that note, this is my final answer, but I can go further and simplify this. This means an inverse, right? So we can bring this down as a denominator. And doing that, so we can write x to the power 3, y to the power 3. And this is to tell you that this is the fifth root, right? Per what we discussed earlier, right? We discussed earlier, So this is the fifth root, this is the fifth root. And all to the power 4. So everything here inside the bracket to the power 4, right? That is our denominator. And we have 3x as our numerator here. 3x squared. And this 5 here is a denominator. So that's it. fxy equal 4y to the power 5, x to the power all over 5, x to the power 3 plus y to the power 3. And we have to find the partial derivative of this function with respect to x and then y. And it's a partial derivative, right? So first of all, looking at the nature of this question, we are going to use quotient rule. So let's find the partial derivative with respect to y. And for quotient rule, let's say if you have the derivative of two functions, f divided by g, we are going to get g f prime minus g prime f all over the denominator squared. So first we differentiate, you differentiate the numerator multiplied by the denominator, followed by differentiating the denominator multiplying by the numerator, and which is bring a subtraction sign between them, all over the denominator squared. So now let's continue. Let's find the partial derivative of this function with respect to y. So we are going to get, we multiply everything, x cube plus y cube by the differential of this. In this case, we are going to do with respect to y. So differentiating y to the power 5, so it's the same as 4 multiplied by 5. Let's say 4 multiplied by 5y to the power 4, the power decreased by 1. Then here we bring minus. In this case, we bring our f, which is our numerator. Write this. We write our numerator, which is 4y5. Then now differentiate our denominator, which is, let's say, but we are differentiating with respect to y. So this term goes 0. Sorry, the x term goes 0. So differentiating y to the power 3 gives us 3y to the power 2. So now let's proceed. All divided by the denominator squared. 3 plus y to the power 3 all squared. So this is going to give us, simplifying this, 4 by 5 gives us 20, right? So 20 y to the power 4. We get 20 y to the power 4, or multiplying 3x to the power 3 plus y to the power 3. Then we have minus 4 by 3 here giving us 12, right? And then we have y to the power 5 multiplying y to the power 2. So we add powers, right? So 5 plus 2 giving us 7. All divided by x cubed plus y cubed all to the power 2. So in this case, you can leave your answer in this form. But in other cases, you might not see your final answer to be this. And to make this simpler, let's simplify this whole expression further. Now, for easier presentation, let's focus on the numerator alone. 20 y to the power 4 x to the power 3 plus y to the power 3 plus to the power 7. So let's expand this. So 20y to the power 4 by x to the power 3 gives us 20y to the power 4 x to the power 3. And this multiplied by this, since we have the same term here multiplying, from indices we just add the powers. So plus 20y to the power 7 is also, yes, minus 12y to the power 7. So in this case, we have 20 of y to the power 7, and we have 12 of y to the power 7. So we can just subtract this, 4 from 20, giving us 8. So we have 20y to the power 4, x cubed, then plus 8y to the power 7. Well, on that note, our numerator now is 20y to the power 4, x to the power 3 plus 8y to the power 7. So our numerator is 20y to the power 4, x to the power 3 plus 8y to the power 7, all divided by x to the power 3 plus y to the power 3 all squared. We can further simplify this. So in case you are not getting your answer, from that is if you are being given options, try simplifying your answer further. Your final solution further. So this one we can further simplify this as we know 4 by 5 gives us 20 and 4 by 2 gives us 8. So we can then represent this as, let's bring 4 out. Then we have a common term y. And the highest of that term is y to the power 7. And this is y to the power 4. So we can bring that y to the power 4 out. And then let's open a bracket. So after y to the power 4, we are left with x to the power 3. So 4 by what gives us 20? That is 5. So plus. And then 4 by what gives us 8? That's 2. We've taken y to the power 4 out. So here remaining y to the power 3. All on x cube, y cube, all to the power 2. So this is our final answer. We cannot simplify this further. I don't know if that exists. So that was for with respect to fy. And now we are going to do with respect to fx, right? So now, so the function is 2 with fx. Looking at this problem, we don't have x term at the numerator side. So in this case, we are not going to use the quotient rule here, but rather try manipulating it to use the either to use other rule. Let's try and see. So anytime you are given a problem which looks like a quotient rule problem, but the term that we are going to differentiate with respect to is not, at both sides, which is the numerator and the denominator, you have to try solving it this way. So we have the numerator 4y to the power 5. So this one, let's bring it up. So it's going to be the inverse of -1, right? So in this case, we can use the chain rule to solve this problem. So using the chain rule to solve this problem, this is one term and this is also another term, right? You can see that it's a product problem, and this also applies to product rule. What we are looking for, if that is not at both sides, both sides, then we just focus on where it is and differentiate it. So this is where we have x. We don't have x here. We cannot use product rule here too. If it's like we have x term here and x term here, so we are going to differentiate this one as a product form. But when we get here, we apply chain rule, right? So let's solve this problem. So leaving for y to the power 5 to be there. This is where our interest is. So we multiply everything by the power, which is -1, multiplying x to the power 3 plus y to the power 3, all to the power -1, and the power will decrease by 1, -1. So this is going to be 4y to the power 5, since we have a -1 here, negative 4y to the power 5, or x to the power 3 plus y to the power 3, all to the power -1 gives us -2. Sorry. So going further, we have 4y to the power 5. This term here is an inverse, so we can bring it down or decide to leave it that way. Plus y to the power 3, 2 to the power 2. The minus sign making it an inverse. So I carry down this become positive, right? So this is our final answer for differentiating this function, which is fx y equal this with respect to x. Find the partial derivative with respect to x and y of ff of f of x and y equal 4x squared y to the power 5 multiplying x squared plus y to the power 3 all to the power 3. So in this case, you can see that we have two terms here, right? So we are going to use the product rule. And the product rule is simply, let's say, if we have a function y, g, multiplying f, first of all, we find the partial derivative of one of them, multiplying it by the other, and then plus the partial derivative of the other multiplying by the other. So if we have about 4 or 5 terms and they are just multiplied, you can use this principle to evaluate them. So now our interest, let's start with fx. For this, we are going to use the product rule. And we are differentiating with respect to x. We have x term here, we have x term here. So we are going to differentiate using the product rule. So if like we have x term here, we don't have x term here, we'll focus on where we have x term and just differentiate that one and go ahead. So in this case, let's differentiate first term, leaving the second term. So we have 4. Differentiating x to the power 2 gives us 2x y to the power 5. Then we leave the other constant 2 plus y to the power 3 all to the power 3. And then now plus, we differentiate this, leaving the first term. So in this case, we are going to use the chain rule to differentiate. So we multiply this by the power, so 3, and then we write everything in the bracket, then we decrease the power by 1. So 3 by 1. Then what we do next is we differentiate what is in the bracket. In this case, we are differentiating with respect to x. So when term that does not contain x goes 0. So this goes 0, differentiating with x gives us 2x. X squared, differentiating x squared gives us 2x, right? Good. So let's simplify this further. 4 by 2 gives us 8, right? So 8xy to the power 5. And then we have x squared plus y to the power 3, all to the power 3. And then we have plus this. So let's bring 2x here. Just remember 2x multiplied by 3. 2 by 3 gives us 6. So x all to the power x squared plus y to the power 3. The power is decreased by 1, giving us 2. So that is for fx. So let's do for fy. So for fy, we are going to do the same. But in this case, and now we are going to do with respect to y. So we're going to get differentiating y with respect, let me write this in order not to cause confusion. So differentiating y to the power 5. So we have 5y to the power 4, leaving the second term constant to the power 3. And now with respect to, we differentiate the second one, leaving the first one constant. So let's say we have the first one to be 4x squared y to the power 5. Differentiating this, we're going to use a chain rule. So we multiply everything by the power, write what is in the bracket, and the power is going to be decreased by 1. So now we differentiate what is in the bracket. So in this case, we are doing with respect to y, and a term that does not contain y term goes 0. So x squared goes 0. So differentiating y to the power 3 gives us 3y to the power 2. So simplifying this further, we are going to get our fy to be 4 by 5 gives us 20 x squared y to the power 4, or x squared plus y to the power 3, all to the power 3. And then we have, from this term, there's a problem from the first solution. But let's complete with this. So we have 4x plus 4x2 y to the power 5. Let's complete this before. So multiplying multiplying the whole of this thing. So we have 3 by 3 here, giving us 9, right? 9 multiplying 9 y squared x squared plus 3 plus y squared to the power 3 decreased by 1 gives us 2. So to further simplify this, we have we have 20 x squared y to the power 4 into bracket x squared plus y to the power 3 all to the power 3 plus. So we can further simplify this. 9 by 4 gives us what? 36. So in this case, we have x. Remember, mind you, all these terms is multiplying this, right? All these terms is multiplying this. So 36, we have x, we have x to the power 2. Then we have y to the power 5 here, y to the power 2. So giving us y to the power 7. Into bracket x squared plus y to the power 3, all raised to the power 2. So that's it for fy. I said there was a problem here. And the problem is here, when we were differentiating the second term leaving the first term constant, we did not write the first term, right? Y to the power 5. So it means this is multiplying this, right? So if we are to further simplify this, we know for this term is right, it's okay. So we have 8x y to the power 5 into bracket x squared plus y cubed to the power 3 plus, in this case, we have 4 by 3 by 2. 4 by 3 gives us 12, and 12 by 2 gives us 24. 24. So now let's look at the variable terms. We have x squared here, and then x here, giving us x to the power 3. We have y to the power 5 here, no y to the power. So y to the power 5 And then now we now bring this term here. I mean this term here, what is in the bracket. So which is x to the power 2 plus y to the power 3. 3 decreased by 1 gives us 2. So this is supposed to be the answer for this. Now with exponential problems, we know that the derivative of e to the power u is equal e to the power u multiplied by the derivative of u. So find the first partial derivatives with respect to x and y, giving us f of x and y equal e to the power x to the power 5, y to the power 3. So first of all, we are going to do respect to x, and we know that with respect to x, we are going to write everything and then differentiate the power, right? We have e to the power x to the power 5, and then y to the power 3. And now we now differentiate the power. In this case, we are doing with respect to x, right? So we just differentiate x to the power 5, leaving y as constant. So differentiating x to the power 5, we have 5x to the power 4, and then y to the power 3. So you can further write this one again as x to the power 4, y to the power 3, multiplying e to the power x to the power 5, y to the power 3. So that's it for fx. So let's do for fy. So for fy, we do the same. We write everything. Then now differentiate the power with respect to y. And differentiate with respect to y, we are going to get x to the power 5, 3y to the power 2. So we can further write this one again as 3x to the power 5, y to the power 2, x to the power 5, y to the power 3. So that's it for this problem. If z equal y to the power 2, x to the power 3, e to the power y to the power 5, x to the power 2. Find zx. And zx means we are going to find the partial derivative of this whole function with respect to x. In this case, we have an exponential term and a normal term. And this term, you will see that this term is normally talking about product rule here. We have two terms multiplying, right? So let's do that. Our zx is going to give us, we are differentiating with respect to x, right? So first of all, we are going to use the product rule. So differentiate first term, leaving the other term constant. Differentiate the other term, leaving the first term constant. So which way you do it, you get the same answer. So we are differentiating with respect to x. So differentiate x to the power 3. We have 3x squared, then y to the power 2, leaving the other term as it is. Then plus, now we are writing the first term, y to the power 2, x to the power 3. Then we now differentiate this. And in differentiating this, you know, is if we are differentiating this, e to the power u, we are going to get e to the power u multiplying the derivative of u. So in this case, we are going to get x to the 3x squared, y squared, e to the power. I'm just writing this. Sorry, this is plus. So now we differentiate e to the power y to the power 5x to the power 2. So first of all, we write e to the power that, and now differentiate the power. In this case, we are differentiating with respect to x. So we only differentiate the x term. So this one will be 2x, right? Differentiating x to the power 2 gives us 2x. So 2x, then you leave the other term as it is, y to the power 5. So we can simplify this further. Mind you, this is our zx. So we have our final answer to be 3x squared. So we have a term here. So 2x and x to the power 3 gives us x to the power 4. y to the power 5, y to the power 2 equals y to the power 7. Then e to the power y to the power 5, x to the power 2. That's it for this problem. Find the partial derivative of the z equal x to the power 4, e to the power y power 5. So find zx. So looking at this, we have a function of two terms multiplying. We are looking for zx. We have x here from the first term, but we don't have x from the second term. So in this case, we just leave the second term as it is and focus on where we have x. So we have x to the power 4. Differentiating this, you guys, 4 x to the power 3, then e to the power y to the power 5. So doing same with respect to y, we have y term from the other term, which is the exponential one term, but we don't have y term here. So just focus on where your variable of interest is. So we have x4, just write x4, and differentiating e to the power y to the power 5. If we are to differentiate this, we are going to get e to the power u dot u prime, right? So this is, let me write this one here again. X to the power 4. So we are differentiating e to the power y power 5. So first of all, we write it, everything. Then secondly, we differentiate the power with respect to, we differentiate the power. So differentiating y to the power 5 gives us 5y to the power 4. So let's further simplify this. We are going to get 5x to the power 4, and then y to the power 4, then e to the power y to the power 5. So that's it for this problem. To find a partial derivative of fx of x and y equal x cubed e to the power 4x y to the power 2. We have to find with respect to x and then followed by with respect to y. So with respect to x, we know that this is a function of two terms, right? So we are going to use the product rule. So differentiate the first one, leaving the second one constant, and plus differentiating the second one, leaving the first one constant. Differentiating the first one, leaving the second one constant, plus differentiating the second one, leaving the first one constant. So let's continue. So we are differentiating x to the power 3, this gives us 3x to the power 2, and then leaving the other one constant for xy to the power 2, and then plus, we are differentiating with respect to x, so we differentiate the power with respect to x of this. So writing the first one as it is, x to the power 3, and differentiating this, we know that e to the power u or e to the power u dot u prime. That is if we are differentiating it. So we write e to the power u, which is u here as 4sy to the power 2. So 4sy to the power 2, and then differentiate the power. But here we are differentiating with respect to x. So differentiating x gives us 1, right? So 4y to the power 2. So let's further simplify our fx to be 3x squared e to the power 4xy squared plus x cubed. Okay, you can decide to bring my 4 first. 4y squared x cubed, and then plus this thing e to the power 4xy squared. So that is it for fx. So let's do for fy. Let's find fy. So with fy, we are going to use the same product rule. But looking at this, from the first term, we don't have y term, right? But we only have y term from the second term. So in this case, we cannot use the product rule. We just focus on where we have our term of interest, our variable of interest, and differentiate that. So we are going to leave x to the power 3 there. We don't need it. It doesn't have, just write it there. Then differentiating this, we have e to the power this, and then we differentiate the power. So multiply by e to the power 4 x y to the power 2. And now differentiating the power with respect to y. So with respect to y, differentiating y to the power 2, we get 2 multiplying by y. So we have 4x 2 multiplying by y. So we can simplify this further. So 2 by 4 gives us 8. So we have 8. We have x here, x here, x to the power 3, x to the power 1 gives us. Find the partial derivative of f of x and y equal ln into bracket x squared plus y squared. So we know that to find the derivative of ln u equal u prime over u. So ln of anything, to find the differential of that the derivative of that, you just find the derivative of u and then divided by u. In this case, our u is all of this, x squared plus y squared. So now let's continue. Let's find x. So in this case, we are going to differentiate all of this and then divide it by all of this. In this case, our u is this, right? So differentiating with respect to x, this goes 0. So 2x all divided by x squared plus y squared. So that is it for this problem. And for fy2, we do the same. We differentiate u with respect to y, and this doesn't contain y term, so it goes 0. So this is going to give us 2y. That is when we differentiate y to the power 2 all on x squared plus y squared. Find the partial derivative of z equal ln x squared over y. And we know that to find the derivative of ln, let's say if we have ln u equal to u prime over u. In this case, all of this is our u. So we have to find, zx and zy. So zx, when we differentiate this with respect to x, we just differentiate. Because we don't have x term at the denominator side, we cannot use a quotient rule. So we just differentiate this. So 2x over y. That's it. So for zy, we have to differentiate. We have to divide all of this by x squared y, right? So this can also be represented as x squared over y divided by x squared on y. So to turn this upside down, we can bring multiplication sign, and then turn this upside down. So x squared. So this, we take care of this, and we have x here and x here. One of these x, we take care of this x. Remaining 2 by 1, which is 2. And then at the denominator side, we have 1 by x, which is x. So the final answer for this is 2 and x. That is for zx, right? So now let's look for zy. For zy, we are going to do the same, but in this case, we are going to differentiate with respect to y. So notice that let me write it here. X squared on y can also be written as, we bring the inverse of that. So x squared y inverse, right? Yes. So let's use this to look for zy. We are using this to find zy. So in this case, our focus is on y, and this one we are going to differentiate with respect to y. So we just leave our x there, then differentiating with respect to y, we have our minus 1 multiply y, minus 1 by y, and the power of y, which is minus 1, will decrease by 1 again, right? All on u, that is x over y. Mind you, this is just the same as, this is u, and this is also the same as u, another way of writing u. which is this. So simplifying this further, we are going to get minus y to the power 2, x to the power 2, and then y to the power negative 2, all on x to the power 2 on y. You know, this one is an inverse, right? So we can write this one as a denominator, ignoring the negative sign. So we have minus x squared all over y to the power 2, then divided by x squared, which is this, over y. Wow. So we can turn this upside down by x squared all on y squared multiply. When we bring multiplication sign, you can turn this whole thing here upside down, x squared. So in this case, y will take care of y, one of y here, then x squared will just take total care of x squared here. We are left with minus 1 by 1 giving us minus 1, y by 1 giving us y. So this is our final answer for zy. So in this case, our zy equal minus 1 on y, and our zx equal 2 on x. Find the partial derivative of w equal z to the power 3 into bracket ln zy into bracket, into bracket e to the power x squared y to the power 3 and then z to the power 4. So we have to find with respect to, we have to find, wx, wy, and wz. And looking at this is a product rule, a typical product rule. We have 3 terms multiplying. Like I said earlier, if we have terms multiplying, whether they are 4 or 5, just use the product rule. You differentiate one, leaving the others. You proceed with that in that manner up to the, up to a point where you are done with each one of them. And don't forget that wx can also be written as dw over dx, and same apply to each and every one of these. So now let's look for wx. wx, we are differentiating with respect to x. So looking at this is one term, we don't have x term here. This here, we don't have x term here. We only have x term here. So we go straight, we focus on that and differentiate, leaving the others as they are. So we have z3 ln z y. And before we proceed, if we are differentiating ln u equal u prime over u, and differentiating e to the power u equal e to the power u multiplying the derivative of u. So let's continue. So this is where we have our variable of interest. So differentiating this, first of all, we write e to the power everything, z to the power 4. And now we differentiate the power. In this case, the power is x squared, y to the power 3, z to the power 4, but we are differentiating with respect to x. So differentiating x to the power 2 gives us 2x. So multiplying by 2x, then y to the power 3 and z to the power 4. So let's further write this as z to the power 3 ln zy multiplying, we can bring, e to the power x squared, y to the power 3, z to the power 4, multiplying 2x, y to the power 3, z to the power 4, z to the power 4. We can bring this constant here, we can bring it out, getting 2z to the power 3, and simplifying the terms in z, we have z to the power 4 here, and z to the power 3 here, making it z to the power 7. You can simplify it in which way you want it, provided it's necessary. We are now done with the x, so let's find, we are done with wx, let's find wy. So wy, we have 3 terms, this, and that. But in this case, only this term and this term has, only these terms have y terms, so we focus on that. So leaving the z there. First of all, we differentiate this, leaving that, and secondly, differentiate this, leaving the rest. So let's start. We are going to differentiate this, leaving the rest. So differentiating this, ln y to the power, ln zy, we are differentiating with respect to y. So ln u equal u prime on u. So differentiating this with respect to y, we are going to get z all on zy. And now we bring the rest. So we have z to the power 3 and then e to the power x squared, y to the power 3, z to the power 4. And now plus, we differentiate this one, leaving the rest. And e to the power u equal e to the power u dot u prime. So we are going to have to the power, just writing this, z to the power 4. And now differentiate with respect to what? Y. We are differentiating the power with respect to y. And this is a y term here. So y to the power 3, differentiating this gives us 3y to the power 2. So we have 3y to the power 2, x to the power 3, z to the power 4. So let's further simplify this. In this case, z will take care of z. And here, we are going to get z to the power 3 all on y. And then this is for all of this. Then let's bring this here. 3y squared x cubed z to the power 4. And now, I'm sorry, this is not what we are supposed to do. This is a product problem. So let me just cancel this. So let's simplify this. This z will take care of this z, remaining 1 of y, 1 on y. So we can write it as z to the power 3 all on y, then e to the power x squared y cubed z to the power 4, right? Plus, then 3 y to the power 2 x to the power 3 z to the power 4 e to the power x squared y power 3 z power 4. We can factor this term out, right? So this will be giving us, let's say, wy or e to the power x squared y to the power 3 z to the power 4 to bracket. After we took this term, we are left with z to the power 3 all on y, and this term remains 3y squared x cubed zy z to the power 4. So that's it for wy. Even in this case, we can even decide to factor z out too, and you will get the same result. And in this case, we have z here to the power 3 and z here to the power 4. So if you bring z to the power 3 out here, this place will be 1 and this place will remain. We're going to have only z here to the power 1. So that's it for y. Let's do the last one, which is wz. We are going to find wz. So in this case, we have z term from the first, second, and the third. So we are going to do it one after the other. We differentiate one, leaving the rest, followed by the other one, leaving the rest, followed by the other one, leaving the rest. You are going to take some of them. We're adding them. So first of all, let's differentiate z to the power 3, leaving the rest. So z to the power 3, differentiating that, we are going to get 3z squared, right? So leaving the rest, which is ln zy e to the power x squared y cubed z to the power 4, right? Then plus, let's differentiate the second one, leaving the rest, right? So for the second one, differentiating this with respect to z. So differentiating z, we get 1. We are going to differentiate this and divide it by this, right? From the formula here, ln u equal u prime over u. So this will give us y over zy. Then we bring the rest, multiplying z to the power 3 and then e to the power x squared, y to the power 3, z to the power 4. This problem is somehow going to be a bit longer, so but let's proceed. And now we're done with the second one. So now we differentiate the last one, leaving the rest, right? So differentiating the last one, we have our formula to be so let's start factoring out. We want to factor out our like terms. We have the exponential term to be a common term, e to the power x squared, y to the power 3, z to the power 4. Now for that, what other common term do we have? We have z to the power 2 here. Let's look at z. We have z to the power 2 here. Okay, that is a common term. And we have z to the power 3 here. Right. Okay. I mean we can bring out z to the power 2, z to the power 2. Then let's see, what do we have again? Then I think that's all. So now after z to the power 2, e to the power this, what do we have? We have 3 ln zy, and then plus. We brought this out and we brought z to the power 2 out, remaining 1. Then plus, we brought this out and then z to the power 2 out, remaining z, right? So we're going to have 4 x to the power 2, y to the power 3. We have z to the power 1 here, z to the power 3 here. Giving us z to the power 4, and then ln zy. So that's it for this problem. Higher order partial derivatives. In some cases, we can be asked to find the partial derivative with respect to a term twice, right? Let's say we can be asked to find a partial derivative with respect to x and x. We should find the partial derivative with respect to x twice. Or f of x, y means we should find the partial derivative with respect to x followed by y. It goes on and on and on. Y, x. It goes on. So this is what is termed by, this is what we mean by higher order partial derivatives. And mind you, this can also be represented as, in terms of x, we can have something like this, dx, and then if the function is f, a function f, you can get something like this. So, which means you should find the partial derivative of f with respect to x twice. So this can be simplified as yes, and this applies to all other variables. So that's it. So let's start solving problems. Find for all partial derivatives of f equal x to the power 4, 4x to the power 5, y to the power 2, plus 2y to the power 4. And mind you, for a function of two variables. In case of this is a function of two variables, which is x and y. We are going to get a total of 4 derivatives, which is we find with x, we find with x f x x, we find with x and y, and then y y y. So let's start. Let's do it. Let's do that. Function is f, so we are going to look for f(x) followed by f(x)(x). We have to find all partial derivatives. So fy fyy. So let's just do that. So for f(x), we are differentiating with respect to x. So we have x 4 by differentiating x to the power 4. We have 4x to the power 3, right? And then plus x to the power 5. So 5 by 4 gives us 20 x to the power 4. We don't have x term here, so it goes 0. So just leave it like that. So we are going to find now we got fx. We want to look at fxx. So we are going to base on that and differentiate it again. We are differentiating x twice. So we base on this and differentiate that one again. Differentiate it again. So we are going to get 3 by 4, which is 12 x to the power 2 plus 4 by 20, which is 4 by 2, 8, 0, and then x to the power 3. So this is fxx. So let's look for fy. For fy, we are differentiating with respect to y. We don't have y term here, so go 0. We have y term here. So differentiating y to the power 2, we get 2y, right? 2y, this is 4x to the power 5 multiplied by 2y. And then differentiating this, we have 2 multiplied by 4y to the power 1, right? 3. The power is 4, decreasing by 1 gives us 3. So simplifying this, we are going to get 2 by 4, which is 8x to the power 5y plus 2 by 4, 8 y to the power 3. So let's proceed. That is for fy. Let's look for fyy. So fyy, we are going to base on what we got for fy and then differentiate it again with respect to y. So now we have 8x to the power 5y here. Differentiating y to the power 1 gives us 1. So we're going to get 8x to the power 5 and then plus we have 8y to the power 3 here. Differentiating y to the power 3. Have 3 by 8 and 3 by 8 gives us what? 24, right? Yeah, 24. Y, the power decreases by 1, 2. So that's it. Find the third partial derivative fxyz of f equal x to the power 3, y to the power 4 plus z to the power 2, x to the power 3, y plus 4x to the power 3, z to the power 4. We have to find the third partial derivative of this. So in this case, we have to differentiate. We have f to be x to the power 3, y to the power 4. So we have to find the partial derivative of this function. But firstly, we have to differentiate with respect to x, followed by y, followed by z. So now, let's do with respect to x. So with respect to x, differentiating x to the power 3, we get 3x squared y to the power 4. And here to differentiate x to the power 3, we get 3x squared, right? So let me write it here, 3x squared, then z to the power 2y. This is x. All right. And then differentiate this with respect to x, we have 3 by 4, 4x squared, then z to the power 4. That is for x, fx, then followed by y. So fxy equal, we based on that, differentiate it again with respect to y. So y to the power 4, multiplying this by that, we get 12, y to the power 3, x to the power 2, plus differentiating y, and it is y to the power 1. So this is going to give us 3x squared z squared 1, which is no need to write it. And here we don't have y term, so it goes 0. So now, first with x, followed by y, then now by z. We have xx, fx, yz, because this does not have two, z terms, so it goes 0. And this we have z to the power 2 here. Differentiating z to the power 2, you get 2z, right? You get 2z 3x squared. So simplifying this further, we get 2 by 3, which is 6x squared z. And now, for the sake of practice, let's find f. Let's differentiate with respect to x followed by y and y. So now, this is a function, right? This is a function right here. So first, we differentiate with respect to x. So we can even jump ahead and come and write this. So we get our fx equal 3x squared y to the power 4 plus 3x to the power 2 z to the power 2y plus 12x to the power 12x to the power 2 z to the power 4. And now this is our fx. We now differentiate with y. So fxy, which is what we got here. Just write that. I said for the sake of practice, but it seems I'm referring to what we did previously. So now with respect to y again, which is fxy y. So we are differentiating this with respect to y again. So this does not with this step, no y term, so it goes 0. So 3 by 12 is going to give us, we are differentiating y to the power 3 since it is with respect to y. So we have 12 by 3 y to the power 2 x to the power 2. And simplifying this, we get 36 y to the power 2 x to the power 2. So that's it for this problem. Quality of mixed partial derivatives. Well, it turns out that if we find the partial derivative with respect to x followed by y is the same as, it equals partial derivative with respect to y followed by x. Yes, and this is what is meant by the equality of mixed partial derivatives. If I have a function that is of 3 terms, variables, let's say, and I find the partial derivative with respect to x followed by y and z, I'm going to get, and then the partial derivative with respect to y, z, y, x is going to be the same. And one thing is that it doesn't matter the arrangement of the variable too. If, let's say, since this is x, y, z, which means you found the partial derivative with respect to x followed by y and z. It doesn't matter when you find with respect to z followed by y and then x, or you find with respect to y, x, z. What matters is that it's the same variable. The differential is in, is to the third term by respect to each of the variable that we are talking about. So the result is going to be the same. So generally, that is for sure. Yes. Prove that fxy equal fyx if f of x and y equal x cubed y to the power 4, 4x y to the power 2. So first, we have to prove that if we find the partial derivative of f, the partial derivative of f with respect to x followed by y equal find the partial derivative of f with respect to y followed by x. So now let's find fxy. So fx equal what? We differentiate with respect to x. So differentiating x to the power 3, we have 3x squared y to the power 4. And here differentiating x to the power 1 gives us 1, right? So plus 4y to the power 2. And then we follow it by finding the differential with respect to y. So this term here differentiate with respect to y. So f x y equal, so we have y to the power 4. So multiplying by y and decreasing the power, we have 4 by 3, which is 12 x to the power 2 and y to the power 3. Hope you are getting that. Plus, and this differentiating y, 2 by 4 gives us 8 y to the power 1. So that is our fxy. Now let's find our fyx. So from the same function, we are going to find fy. So fy, we are differentiating with respect to y. So multiplying 4 by the term y, decreasing the power by 1. So we have 4y to the power 3, and then x to be there to the power 3. And here we have differentiating y to the power 2, we have 2y. So 2 by 4 gives us 8x and then y, right? So now we are going to differentiate it again with x. So we have fyx, so which is of this. So differentiating with respect to x, we have 3 by 4, so which is 12x squared, then y to the power 3. And then plus differentiating this with respect to x, differentiating x to the power 1 gives us 1. So we have 8y. So now it is confirmed that this is equal to this. Find the partial derivative of z equal sine into bracket x to the power 3 y to the power 4 with respect to x and y. Let's say we have to find zx and then zy. Now this is a trig function, right? This is a trig function, and to know we know that derivative of sine u equal cos u multiplied by u prime, and it follows these are trig identities for differentiation, and then I advise you to know them. But in case you are wondering, you can use this Cartesian plane. So it means that when we are going this way, we are differentiating, right? But when we are going this way, we are integrating, right? You have sine, sine, cos, cos. So if you differentiate sine, you are going to get cos. If you differentiate cos, you are going to get negative sine. If you differentiate negative sine, you are going to get negative cos, right? If you differentiate negative cos, you are going to get a positive sine. So that is how it is. If going clockwise is differentiation, and going anti-clockwise is integration. So I'm going to find my zx and zy. So zx is going to give me, differentiating this is going to be cos of this. So I have cos of all of this, x to the power 3, y to the power 4. And then now I differentiate what is in the bracket. But I'm differentiating with respect to x, so just the x term to get 3x squared y to the power 4. So that's it. You can rearrange it in the other way around, which will be 3x squared y to the power 4 cos x cube y to the power 4. So now let's look for zy. I'm going to differentiate zy with respect to, I'm going to differentiate this with respect to y. So in this case, it's going to be the same cos, since still sine. So we have cos x to the power 3, y to the power 4. Then differentiating this term with respect to y. So you're going to give me 4y